Let's start the live streaming and then we can start the lecture right away. Let's start the live streaming and okay, I know. Let me share the screen. People on Zoom, can you see the right screen? I'm sharing the slides.
Yes, we see the right one.
Okay, perfect. You can hear me, I assume.
Yeah.
You can see the video, the YouTube's working.
Everything looks great, yeah.
Perfect. Get rid of this. Yeah, I want to minimize this, but let's keep it. All right. Hello, everyone. So welcome to the new semester, new start. This is the first lecture and seminar in computer architecture. I'm Mohammed Al-Sir and hope all of you are here for this course. And thanks for joining in person. Actually, it's a great experience to have it after a very long break. We have all the courses online. So let's see how this semester goes. Okay, so I'm senior researcher and lecturer at ETH since almost 4 years, and I'm mainly focusing in bioinformatics. I got my PhD in bioinformatics, plus building computer architectures, hardware designs for genome analysis in Turkey, Bilkent University. That was around 2018, and I got the IEEE dissertation award at that time, and then I joined ETH. This is the best way to reach me, the Twitter. I'm mainly focusing in bioinformatics, computational genomics, microbiome discovery, but all related to algorithm building or algorithm development, building hardware architecture, hardware designs, and so on. So it's very relevant to what you have. And if you took computer architecture course with Onur Mutlu, probably you watched some of my lectures on genome analysis and how they are closely related to what you are studying, basically, either developing software or hardware. Okay, so what are the things that we are doing at Safari Research Group at ETH? So basically, we are building better computer architecture, hardware, software, code design, and systems for bioinformatics, hardware, software security, and many more. So basically, we build fundamentally better architecture, regardless of the application. You can pick any application you would like to improve, and then you can either improve the general purpose computer that we have, or you specialize the architecture to improve the execution of that application. So mainly we have 4 directions. The first one, to build secure, reliable, safe architectures. Probably you heard about RowHammer problems, where you perturb the row accesses in the DRAM, and then you cause some illegal accesses to something that you are not supposed to access. And we build fundamentally energy efficient architecture. Especially we are talking about low power architecture, you know, in some application, especially the portable devices, as all of you have. So those, you have a lot of constraints over there in terms of cost, low power, portability, area, energy management, and so on. We are focusing also on low latency, which is very important for health applications, including genome analysis. You would like to go to the hospital, get some of your DNA analyzed, and then want to know what are the causes for disease or pathogen, for example, and you want to know that very quick, especially in life-threatening situations. For example, think about babies who would like to survive in a few days, want to know what is happening over there so you can prescribe a medication and so on. Regardless, those 3 directions, it's very exciting as well to build architectures for applications, including machine learning, artificial intelligence. These days, most of the companies are focusing on building customized chip just to do one single application, which is really something exciting to work on, especially when you see the impact of all those applications in our life. Probably all of you are aware about the computing stack, of course. So you start here either from the computer science problem that you're trying to solve or the data itself. So you have a huge amount of data. You would like to make it more efficient before you start to process it. After you build the algorithm to solve the problem, you would like to implement it. So the operating system probably is managing the interpretation or the conversion from the software to the hardware. So you need the software-hardware interface, and then the microarchitecture and the support from the processor itself. And then you go all the way down to the transistor level or the electrons. Traditionally, we are focusing in computer architecture courses or digital design around the processor, very centric around the processor itself. So either you can build microarchitecture to support more operation, for example, but at ETH or the courses that we provide at Safari Research Group, we span the full stack, basically. Even not starting from the algorithm, but the data itself, basically. So you have a huge amount of data. You want to support compression, for example, right? You want to compress the data first, make it smaller, and then start the processing. That may require decompression, maybe not, right? If your algorithm is smart enough, you could process the compressed data without decompression. And we have few examples on that on genome analysis, for example. But you could build a better computer architecture that can understand, for example, the microarchitecture. You support wider range of operations, for example, if they are widely used, for example, for many applications. Now, looking at the computing stack, it might not be always wise to work at the microarchitecture level. Because, okay, you build an architecture, but also you want to support it at the software side, or you want to support handling the data more efficiently. So it will be wiser to look at the stack from the top as well as from the bottom. So you have a huge space for improving the computing stack from both sides. And always the best algorithm or the best design or the best work that work at the two sides, the software itself or the algorithm and the hardware. So you need to build a very efficient algorithm first that is aware about the hardware you are using. So if the hardware is supporting certain operation, it will be wiser to use those operations and support them in your implementation. And then you could support also the hardware itself to implement or to run your algorithm efficiently. So you need basically, that is in most of the best case designs, to build an efficient algorithm and build efficient architectures. This is a very simple example. I'm sure all of you are aware about matrix multiplication. Very simple thing. You have 3 nested for loop, and you want to compute something like that. So you have the first row times the first column, and then you multiply the first element here by the first element. You add it to multiplication of the second element with the second element over there until you got that first element, right? Very easy. Now let's see the effect of handling this using software and hardware, or one of them. So if you're going to implement this very simple implementation using Python, you got 1x, which is the baseline, okay? Now you move lower level and you go with more advanced programming languages, such as C, then you can achieve 50x of speed up. That there is no special customization or optimization here, just pure implementation. Now moving further to further optimization and do software optimization, you could achieve, let's say, more an order of magnitude of speed up, right? But moving to the hardware, assuming your microarchitecture supporting SIMD units, for example, single instruction, multiple data units, where you can apply an operation to many data at the same time, and then you can gain about 3 to 4 orders of magnitude. That's why, hopefully, I emphasize it good enough that you really need to worry about the software as well as the hardware implementation. And if you combine both of them, you will get a very efficient solution. Do we have any question? Okay. So to achieve the highest performance and energy saving, we must take the expanded view of computer architecture, which is spanning the full stack. Of course, we are not talking about these very low level because you need industry to work at those and manufacture them or fabricate the chip once you change it, right? But at least you still have a huge space for improving all those steps in the computing stack. So we need to co-design across the hierarchy, of course, software, hardware co-design, and specialize as much as possible. Of course, when we talk about general purpose computer, we cannot generalize much, but sometimes you could support some of the important operation where you have special cores with very low overhead, very small area that you can occupy, for example, supporting data compression, assuming this is supporting a wide range of applications. Okay, so maybe this is repeating itself. To build fundamentally better architecture, we need to worry about data-centric architecture. What do we mean by data-centric? So the all general purpose computer are compute-centric. So we move the data from the storage to different memory hierarchies, all the way to the CPU to process the data. And then we dictate all the units to send the data from long journey all the way to the CPU to do the processing. And as you know, the data might be useful, might be not. And if the data is not useful to the computation and you move it all the way back and forth between different memory hierarchies, you are wasting a lot of time and a lot of energy. So it might be wise to think further about the data itself. And then if you assume it will be useful, you can send it wherever you want. But if it is not useful, it will be wiser to filter it out as closer as possible to the storage or where it's located. And that's why we call it data-centric architectures. This includes processing in memory, using DRAM, processing in storage, processing in cache, wherever you think your data will benefit more by filtering out these data at this stage. Again, when we talk about low latency, there are very important application that you would like to get the results as quick as possible. We mentioned the health applications, but there are also other applications, for example, military services, where you have some sensors, you got stream of data, you want to do the processing at the edge and very quickly so you can take the right action right away. You can customize the architecture for application and so on. So that is what we call Safari Research Group at ETH, led by Professor Onur Mutlu, who joined ETH in September 2015, was at CMU before that, and then he was working in industry before joining ETH. And his research interests span everything we mentioned just before. If you want to know more about our research group, we normally summarize all our activities, achievement, everything we do within every 6 months in a newsletter. So this is the recent one, was end of the last year, this is early last year, and this is the year before. I think all of them were through the pandemic. Hopefully we'll have some online activities as well. All right, we have a large number of PhD, postdoc alumni. You can check their profile, the things that they do. Normally we publish or we post their thesis, their defense presentation, everything public online. So you can go to the Safari website and access them and learn more about the things they achieve while they are with us. This is a video you can watch to learn more. If you want a summary of 15 minutes about the research group we had. This is the video. And we are teaching 3 major courses: computer architecture, digital design and computer architecture, and seminar in computer architecture. How many of you took any of those 3 courses before? Perfect. Almost half the class. Okay, perfect. So we have also a large number of PNS courses, project and seminars. This is the resources. This is, for example, digital design, computer architecture last semester. This computer architecture offered once a year. This is the seminar from the previous semester. If you are smart, excited about this course, I would recommend everyone to check the previous semester, see what are the things that the student normally do to pass the course. They do the expectation, and some of them even exceed the expectation, and they join us to do research at our group. So as I mentioned, we have, I think, about 6 to 8 hands-on courses. Those normally for undergrad, but we welcome everyone to work on projects related either to bioinformatics, dealing with DRAM, with the security, with processing and memory, and many more topics. So normally we assign a project to each student. Those projects normally part of our own research, and then we give you some lectures, teach you the basics, the things that you need to move on, and then you carry out all the practical project throughout the semester. So within 3 years, we expect you to finish 3 months to finish the project, and then normally that lead you to a research paper. So normally we publish the work that you do through the course. But you'll get intensive help from all of us. So normally we assign 2 to 3 mentors that help you throughout the semester to finish your project and write your paper. Maybe some of you here doing research with us, I see some few examples. You can check with them. We have also the mentors for the course sitting in the back. They are going to introduce themselves very soon. So that is the genomic course where we teach the student about the basic. Again, in all these courses, you don't need any kind of knowledge about bioinformatics or what is genomics or all these things. We will teach you all this stuff, but we require, I think, good knowledge in C. Some people send me emails, what is good knowledge? So it's really hard to define. As long as you are comfortable in programming in C, that is perfectly fine for us. We are going to teach you all the needed for the project. These are several courses. These are live seminars. Normally, we invite people from different institutes, different universities to give talk. I think every week or once in a while, every 2 weeks, we have a new guest that presenting about something hot topic or trendy in this area. So you're welcome to check the channel on Safari website to see what is going to happen next. So I think we schedule already live seminars until the end of the year. So we have, I think, about 6 to 10 more seminars. Those are past examples. As with all our research, everything is open source. Everything, hopefully, is reproducible. So the source code is in the GitHub, all the instructions needed, the data, everything over there. So if you are excited about any of our work, you could download the source code, run it, and see if there are issues. If you have some weaknesses in mind about the work, then you can improve it. Send us email, say, I figure out there's a weakness here, or how about trying this out? How about improving this? And then we can talk. So these are the 3 resources that I recommend everyone want to know more about what we are doing in the group. So the first one, all the publication we have. The second one, all lectures, everything we have on YouTube, and then the GitHub page. All right, some basic principles that we follow in the group. So, as all of you are aware about the importance of doing research, so teaching and research go hand in hand, and there is no advancement in research without teaching. There is no advancement in teaching without doing research. So both of them really important. That's why even the industry is focusing on teaching. Teaching doesn't mean here giving courses, but you need to teach the junior people so that the senior people improve the things or advance the projects. So teaching drives research and research drives teaching. That's why most of our courses already involve topics about what we are doing in terms of research, which is very important, and keep you updated about the things trendy in computer architecture, for example. So if you join other computer architecture courses, you may not hear anything about genomics, for example, or bioinformatics, right? Or machine learning, and so on. In most of our courses, or as you will see in this course and seminar course, we focus on insights and we encourage new ideas. So your goal is not just to present an existing paper, but rather you're going to extract insights from the paper, and you will do your best to extract new ideas about the paper. So you already extract weaknesses and you extract some strengths about the paper, saying that this method may not work. There are another paper presenting something else as a solution for this. How about we use this and that? And starting from those ideas, students join us and try to improve whatever they extract or they observe in this course. We focus on learning and scholarship. That's why we assign you several mentors through this course. And those mentors normally are the authors of the paper that assigned to you to present. So either as main author of the paper or someone who's knowledgeable about the paper. Because we care about you, we want to teach you the basic before you present it. So we really care about what you are going to present. That's why in the background, we have a lot of meetings with each of you to prepare you for the presentation. So we don't ask you that, here's the paper, just come and present it. But there is a lot of ongoing things in the background that people or other students may not see, preparing you for the final presentation day. We create an environment that values free critical exploration, openness, collaboration, hard working, and so on. How is that possible? Again, we assign mentors to you. Those mentors are very knowledgeable. They share ideas with you, give you some insights, some hints about how about you check this relevant paper that was recently published, and they present this idea. How about you check it? And then once you check it out, you may gain more insights, more ideas, and then it will help you to have fruitful discussion for your presentation. And this is how we collaborate with you. We don't dictate you to do this and that, but rather we share knowledge with you, and then you share ideas. How about if I do it this way? No, this way didn't work. Try this out and try that out. So we had several meetings with the student, as I mentioned, just to share an experience and teach them how to present. And that is not about the seminar itself. So the seminar at the end is just a course with low credit. You will pass it, of course, if you do the minimal or if you prepare well for the presentation. But at the end, this is preparing you to do research, critical thinking about research subjects. So think about doing master's or PhD or any of those grad studies, and then you are going to work on a project. And in this project, you will pick a topic, and then you will say, what is the state of the artwork in this field? And then you pick a paper that is really the best. But then you need to critically analyze it and extract some weaknesses. This is how you'll progress in your research. And this is what we are focusing on in this research, regardless if this is computer architecture or something else. You need to follow the same principles, same concepts to analyze any existing paper. The quality of your work defines your impact. What does that mean? So it will be very obvious from the way you present. If you are very confident about what you are presenting and you present it in a very clear way, you convey the message to general audience, that is going to increase your impact. So normally in the past semester, half of the class decide to have their talk live streamed on YouTube, and the other half decide to not, to keep it offline. Of course, those who decide to keep it online, they increase the impact. Because in our YouTube channel, for example, we have a lot of people from industry, from many companies, also from other universities. They are watching you. And you are given this chance, which is very rare, that you present to all of those people at the same time for free, right? You got the access to this platform, and you need to exploit this platform very well. So that chance, we encourage you to leverage it, to exploit it, to present your talk, prepare very well, and then the video will stay there forever, maybe 100 years, 1,000 years, right? And that's a great example on the effort that you spend in this course to get with that presentation. As I mentioned, the presentation by itself, it's about 30 to 40, 50 minutes, and then what? And then the impact you leave over there. Maybe someone's going to analyze that paper, they're going to watch your presentation and then get some insights from there. And then it will be obvious that you spend really a huge effort to get into that stage. And you can make a good impact on the work. Don't minimize your effort, even if it is just single paper presentation, still matters, right? Follow your passion. Don't get derailed, even by our own comments. So even once you are presenting, normally we comment in your presentation and we say, you didn't do well here, you do well there. this is very good, this is excellent, so on. Or maybe from your colleagues, they were going to start fruitful discussion after your presentation. They were going to ask you about several aspects in your presentation, right? Don't get derailed by that. That is something to progress in your research, and you have to be comfortable about discussing, answering any question you get, because that is the actual environment in conferences. Once you go to a conference presenting your work, you'll get questioned by senior, by expert, by maybe beginners in this field. So you have to be comfortable with that. You need to build infrastructure to enable your passion. Infrastructure doesn't mean equipment, but means everything to enable the success of your passion or of your project or of your presentation. Of course, working hard here is the main thing. You don't need to be smart, but you need to work hard here, right? Because there are some rules how you get an excellent presentation, and those rules or those steps, we're going to show you step by step how you reach to a stage where you deliver an excellent presentation in this course. Be resilient, focus, work hard as well, so you make it happen. You can make a good impact on the world again by doing a good job. And as I mentioned, this video will stay forever on YouTube. Don't be shy to make it online. Of course, we offer you 3 options. Make it offline for good, or make it live streams in the same time you present, or after your presentation, you decide whether you want to make it online or offline, okay? But we encourage everyone to make it online, because even myself, if you check my videos like 5 years back, my quality wasn't that good, wasn't as now. Even for any professor, if you check their videos online, you'll see the quality is improving, right? This is how you teach yourself, how you improve yourself. So don't be shy about whatever quality you get at the end, but it will encourage you to improve more, right? Whenever you watch that video, maybe you'll laugh on yourself, but at the end, you'll improve yourself more, and you'll say, okay, maybe I can do this better. Let's improve next time. Next time, I'm not going to do this. Let's do it this way. Otherwise, without trying, you will be scared all the time whenever someone will tell you to present online with small audience or large audience, right? Okay, so this is a research article, not research, let's say summary paper, 18 pages. This is from American scientist who invent Hamming distance. How many of you heard about Hamming distance? Error correction communication, perfect. Yeah, so this is Richard Hamming. He has a nice summary of how to be successful in research. So we have to focus in the first few lines. So to be a first-class scientist, you need to know yourself, your weaknesses, your strengths, and your bad faults. That's why you will learn a lot from your faults. Whatever you are shy, scared from not doing it to the public, you will stay scared all the time. Whenever you try to do it and you do your best to do it, you will learn and then you progress. So to be a first-class scientist or world-class scientist, you have to try. Doing faults is not a bad thing. We recommend everyone to read this 18-page paper. Maybe you can read it in the summer or through this semester. All right, so now let's start with the logistics of the course. Do we have any question before? Okay, perfect. Hopefully that is a sign that everything was clear. Okay. So hopefully all of you here for the seminar in computer architecture. So what is computer architecture? Science and art of designing computing systems, including hardware interface, systems, microarchitecture, and so on, right? Why we design better computer architecture? We would like to achieve better goals and a set of goals based on the application. So these goals, they are not the same. Depends what we are targeting, what we are trying to achieve. So one of the goals could be highest performance on Earth, for example. Very ambitious, right? That's why countries are building their own fastest supercomputer, right? They're always in race. Which country is building the fastest? So 2 years back, Japan built the fastest supercomputer. this year, US, and so on. This race is continuing. Could be the longest battery life, as in all self-drive cars, all of them in a race to have the largest, longest capacity batteries, the easy to charge, and so on. The cost could be a constraint here as well, right? You want to have something to be affordable by public. You don't want to build very expensive car that few people maybe can afford. Or you want to build the best average performance. Shouldn't be the highest all the time. We may not need supercomputer to do simple computation, as for example, just streaming a data show or presentation to the device, to the board, right? So it really depends on the goal here. Of course, designing a supercomputer is different from designing a smartphone. Each has its own constraint: portability, low power, low computation, for example, low cost, the area of the design. So in this course, we will cover fundamental and cutting-edge research paper in computer architecture. And as I mentioned, computer architecture doesn't mean just only the computer we have or hardware for general purpose computing and so on. It could be focusing in a very specific application that you are interested in. And we have normally a large list of papers that we give to you. We ask you to show your preferences within a certain time, a week or 2 weeks. And based on your preferences, we are going to assign you that paper. So we have multiple components that are aimed at improving the student technical skills in computer architecture. So you're going to study a topic that you may didn't study before in depth, of course. Critical thinking and analysis, because you're going to question everything in the paper. Why the author did it this way? How about doing it the other way around, right? There are multiple works. You will see them in parallel, all of them. For example, we assign you one paper, yes, but there are a lot of related work to that paper. And we normally ask you to study all of these papers, or the best of them that are relevant to the paper. And then when you see the full picture, that this work did this work spans something else, the other work maybe discovers something totally different, but solving the same problem, right? And then by seeing the 3 pieces of work, then you get more insights that this method is not the best. This method can be best for this workload and so on. This is how you start critically thinking about any problem, which is true about anything in life, right? When you face any problem in your life, you'd like to think from past experiences that, okay, my mom told me to not do this in future, or my dad asked me to not do this because this is going to cause that. And that is critical thinking. You have a feedback from previous research papers or previous experiences, and then you are going to act based on what you learn. So technical presentation of concepts and papers, that is not only your part, but also your colleagues. So they are going to present as well, and then you will learn from their mistakes. And then by the time your presentation is coming, you decide to not do it that way, or you are going to present this way. Or maybe you see the audience are a bit bored about what you are presenting, then maybe you can change your tone while you are presenting, go loudly, slowly, maybe ask them, do you understand? You provide questions to them. This is how you motivate them, right? Rather than just keep explaining things and move slide, and then all of them are sleeping. Hopefully you're not sleeping, right? Okay. So the technical presentation will be both in spoken and written forms. How is that? So you'll present, okay? And then at the end of the semester, you're going to submit a synthesis report summarizing or answering some few questions that we ask you to answer. And if you want to check an example of the synthesis report, check the previous semester or the one before and so on. So in each semester, we ask the exact same questions. So if you check the report, maybe you can answer it meanwhile while you are watching the presentation of the others, because there are some questions related to the course itself. Do you recommend it to your friends, what you learned, and so on? These are very traditional questions, but there are questions about the presentations. Can you classify them into categories? For example, what are the paper that you like the most, for example, and so on. Second most, third most, and so on. We will give you familiarity with current state-of-the-art research. Most of the paper are state-of-the-art, but there are some seminal work, very fundamental, maybe proposed in the 70s, 60s, and so on. Those still have impact until now, including processing in memory, for example. So the first processing in memory paper was proposed around the 70s and still showing an impact even these days, right? What is the key goal for this course? Hopefully all of you can know the goal without looking to the slide. So you have to learn how to analyze, present, discuss paper in rigorous, thorough method, right? And ideas in computer architecture. So we'll give you the algorithm, what you need to follow step by step. We're going to assign you mentors, and that is a lot of resources just for you to pass this course or to succeed. Plus, you'll have feedback from your colleagues, right? They are going to present every week, 2 presentations a week. And then from those, you can learn a lot, right? So you have a lot of things just to help you passing the course. Here's an algorithm for the presenter, for the participant. We have also an algorithm for the mentors who are sitting here in this room, right? They're going to help you. They also follow an algorithm how they are going to help you. But that will keep it offline. Okay, for the presenter, again, every week we'll have 2 presenters, 2 presentations, right? And those presenter, they need to read, absorb, read more about the paper, and not only the paper get assigned to you, but also other resources. So we're going to ask you to check many other papers that are very relevant to the paper. Also, the mentor is going to help you in that direction. So you pick the right paper, so you don't read just and then you waste some time, and then at the end you don't gain anything from that. You need to critically analyze, think, synthesize. When I mention mentors, they're not going to do the job for you. They're not going to give you the weaknesses of the work. They're not going to give you the strength of the work, okay? Hopefully that's clear to you. That is your job to critically think about each of these work, but they are going to somehow put you on the right path towards discovering these weaknesses. They are going to mention some hints, some insights that, how about checking this? Please check this page, this paragraph. There is something here. Maybe reformulate the weakness. Maybe you have it in a weak manner, but then we'll ask you to strengthen it more, fortify it using these statistics and so on. After finishing all the meetings with mentors, then you need to prepare the slides or finalize them and prepare for the talk. And then you present, you answer some questions from the audience, or you initiate the discussion. So it's not like exam. They're going to ask you some question. You have to answer the right answer, right? We are here to help you and discuss. So you could initiate the discussion. And they are not the only one asking, but you as a presenter, you need to ask the audience. So ask them some questions such that you dictate the discussion. You put it in some specific direction. You can ask them about relevant paper that you already study and prepare. So give them a question, wait some few seconds, minute, and then move on. Show them the answer and go to the next question. This is how you initiate successful discussion. For the participants, which all of you will be most of the time, so you're going to present once, but all the rest of the weeks, you're just attending or participating in the presentation. You need to discuss, ask question, analyze, and synthesize in meeting, after the meeting, and throughout the entire course. And to discuss something while someone is presenting about it, if you didn't read the paper, it's not going to help you, right? You need at least to scan the paper, know what we are talking about. And in some of the presentation, you'll see that the same paper was presented in the past courses of the seminar. So it will be great if you can watch these videos and come prepared to the course. Of course, we don't ask you to do that all the time. Skimming the paper, that's good enough. At least you are knowing what we are talking about for today. And there are some papers, for example, close to your heart, like you really like this topic, for example, and there are some topics that you don't like. That's why sometimes you do really great in the discussion, sometimes you don't do great. We try our best to cover all these topics. So from each topic, we have 5, 4, 10 papers. So we almost covering all flavors, hopefully. But if you feel something you really need to talk about, we would be happy to discuss it over email. You can send us a paper. Hopefully it's top notch. Please pick the best paper so that everyone will be will find it useful to them, right? Okay, some goals of the course, just to recap and refresh. We would like to teach you, enable, and empower you. Think critically, think broadly, learn how to understand, analyze a paper. Again, this is not about computer architecture. The same concept applies to anything in life or any domain. Whatever your interest is, computer graphics, same thing. How to analyze a paper, there's an algorithm you have to follow, and then ask expert in the field, get some feedback from them, and then get weaknesses, try to solve these weaknesses. Get familiar with the key first step in doing research. As all of you, this course for master's student plus undergrad as well. So to do research, you have to follow some algorithm, right? Of course, you can come up with your own improvement to that algorithm, but of course, first you need to try the algorithm first and see how it works. If it is beneficial for you, then you may come up with some improvement to the way we do research. Get familiar with key research direction. As I mentioned, all of the things we present are state of the art, and they are very trendy, either this year published or the year before. So that is the state of the art, right? And if you start from there, then you are sure that whatever you improve is novel. Hopefully it's not incremental improvement. Okay, that is to put it in a diagram. I know all of you like figures more than text, more than talking. So the first step to read and generate some critiques about the work, question, brainstorm. That's why you meet with mentors. So ask them whatever you don't understand about the paper. They're going to help you, and they may assign you different other resources to read and check. Develop new out-of-the-box ideas. What does that mean? Are you going to do research projects in this course? No. So ideas doesn't really need to be very strong, very valid. It's okay to propose ideas. How about we do this? Because you took some other courses. So you may come up with ideas from past experiences, right? From other courses. Just how about we use this machine learning algorithm was solving similar problem in different domain. How about we use it here? And that is true even for bioinformatics. So I have a lot of experience in bioinformatics, and I can say now that most of the algorithms are not invented for bioinformatics. Most of them were used in the past for text search, for example, or speech recognition, or a huge database processing, for example. So we reuse these algorithms. Of course, there are some tweaks because now the data is different and maybe the requirements are different. For example, accuracy is a must in bioinformatics. You don't want to show inaccurate results saying this guy has this disease, but he does not, right? That is very critical. You need to collaborate. That's why we assign you multiple people, not just one mentor. So all of them there to help you. They have different flavors, different research interests. So hopefully that will help you a lot, because if you explain the ideas to someone who is not from computer architecture background, that is the best. If you succeed to help them understand the concept, then you are the best. That is the perfect presentation, where you convey the message with examples, with everything, until they really got the idea of the work. And after you do the full cycle is to publish the work. There's no use of something that you did for 2 years, you did great work, and then you close the source code for the work, right? What is the use? Unless, of course, you're going to start your own startup and commercialize the product, that is something else, right? But there is no use to not keep your project open source, publish it to the public so they can discuss it, publish more, improve it, and so on, right? And that is how research works. And then once you finish the project, you figure out that there are more space to improve, then you repeat the cycle. Okay, now let's jump into the course info. More about the grades, what you need about this topic, and so on. So as I said, this course, we have 3 lecturers, Onur, Mutlu, me, and Juan. Basically, you came to know us more throughout the course. We have also a large list of mentors. I think some of them here. I'm not sure, Muhammad, I'm not sure if he's online. Not online. Who's here, Rahul? No, I think we can start from Girai. Girai, can you introduce yourself? Maybe Joel, can you help handing this? Thank you.
Okay, I'm Giray. I'm, I think, 4th year PhD student now. I'm working on RowHammer mainly, but in general, DRAM reliability, energy efficiency, all those problems. So what else should I say?
Yeah, perfect.
Okay.
Yeah, feel free to ask whatever you want to ask.
Yeah, if you have any questions, I can take.
He's doing great work in DRAM security, preventing RowHammer and all this stuff.
Okay.
Yeah, thanks, Girai.
Yeah.
Who's next?
I'll go next.
You will.
Maybe someone already wants.
Maybe you can come here so the people on Zoom can see you as well for the camera.
Sure. Hi, Zoom. So I'm Joel. I did my master's and bachelor in computer science here at ETH. I started about 1.5 years ago working with Safari, and then I'm first year PhD student with them. Work mainly on bioinformatics from the algorithmic side, but also interested in heterogeneous computing, so GPU acceleration, FPGA, ASIC acceleration. So yeah, that also drives an interest in more general, say, heterogeneous computing. So also interested in just pure architecture from that side. Yeah, so excited to be working with you.
All right, cool. Thanks, Ruel. Have Geraldo.
So hello, everyone. I'm Geraldo. I'm a 4th year PhD student. I work mostly on processing memory and in general processing memory, processing using memory, processing near memory and system designs. I guess we are going to cover some of those papers in this seminar class. So I'm looking forward to send you a lot of reference for you to read when you meet and complain about please put more animations in your presentations. So usually what I do.
He's trying to scare you, right? Not pick him.
But it's a lot of fun. It's a lot of fun.
Yeah, I agree.
Yes.
Yeah, thanks, Geraldo.
Thanks everyone.
Konstantinos.
Yeah, hi everyone. I'm Konstantinos. I'm a 3rd year PhD student.
Come closer. Yeah.
And I'm working on the topic of hardware-software cooperation, co-design, the interface between the operating system and the hardware. And I'm really happy to discuss with you papers which are on topic or any other topic. As well.
Are you going to assign a lot of papers?
Yes.
No,
Yes, unfortunately, this is the case.
it's so much fun. So much fun.
It's for me.
For everyone, I believe. It's a great experience. You need to exploit all these resources. We really give you a lot of things in this course, and you need to just leverage them, right? Just for your success.
Yes, exactly. Thanks a lot, Mohammed.
Thanks, Konstantinos. Rakesh.
Hello, I'm Rakesh. I'm a 2nd year PhD student in this group, and I mostly work on storage systems, hybrid systems, basically hybrid memory and hybrid storage. And I also want to work on machine learning and computer architecture. So these are my areas of work. I look forward to discussing papers with you all. Thank you.
Perfect. Thanks, Rakesh. We have John.
Hi, hello everyone. I'm John. I'm a PhD student as well. Fifth year also, I guess Giray should be fifth. Let's correct the calculation. And I'm working on the problems related to bioinformatics, gene editing, and accelerating genome analysis. So yeah.
All related to computer architecture, by the way. Yeah, don't get scared from the names. Thanks a lot, John. All right, so that is covering almost half of the mentors. We still have more people, but they are busy with the dry rounds for conferences. We have micro next week. And I invite all of you to visit the website over here. You can know more about other people, what they are working on and so on. Okay, let's move on. What are the requirements? First, attendance is a must. Please, cannot compromise that. So you have to attend all meetings. We can afford missing at most 2 meetings with a reason. So you need to send us email that you're going to miss this for that reason, okay? And for that, it's not going to affect your grade if you miss these 2 meetings. But attendance is a must. And we give you the option either in person or online, but we prefer in person because the best interaction, as you can see, you can laugh, you can smile, you can see your faces and all this stuff, right? We don't want to lose human interaction. So each student will present 1 paper. That is, I think, not a heavy workload, but you need to work a lot to get the presentation in really perfect shape, right? So you prepare the presentation, discussion, and the synthesis report. Those your duties. Non-presenters need to participate. Participation is a must here. You need to participate in all presentation. We have about 30 minutes for the presentation and then another 20 minutes just for the discussion. And we would like to hear everyone. Just share whatever you have in mind. Don't think it will be silly or someone is going to laugh. We are all here to learn, even me, myself, okay? And after each presentation, we will have a short multiple choice questionnaire. And for each presentation, we'll have only 5 questions. So each week we'll have 2 presentations and that is 10 questions, okay? And that will be very short, direct to the point. Without studying the paper, just by listening to the presentation, you should answer all of them. And we give you 24 hours to submit your answer. Hopefully that is fair enough for all of you. Again, without studying the paper, only by watching the presentation, you could answer all these questions, hopefully. If you have any complaint, just send us about any of the quizzes. But we give you 24 hours. If you have, again, any other restrictions preventing you from submitting it within 24 hours, just send us email, okay? Everyone comments on a paper. So normally we have a Moodle system to discuss each of the presentation. If you have some other resources, maybe you find a video on YouTube, for example, or some other paper discussing some other points that you ask question to presenter, maybe he didn't or she didn't answer the question probably. So you can provide resources on Moodle saying that I'm going to create this thread about this paper, I find this resource, this idea, something like that. And all of you are free to, whatever you create a thread on Moodle and start your own discussion. Hopefully it's fruitful, okay? You can ask general question that you think might be beneficial for everyone, for example. So please leverage the Moodle to enrich the discussion. The synthesis report is about, I think, 3-4 pages. As I said, 2 halves. The first half about the topics presented in the course, the second half about you. You want to learn more about whether you want to do research with us, or maybe other research groups. And if you want to do research with us, what are the topics that you're interested in? What are the key ideas you get from the paper you presented and so on? That will help us to get back to you. We will contact you at the end of the semester. and offer you something, either thesis, topic, semester project, short-term project, or do studies with us, okay? So the website for the course is already updated and online, so you can check it now. All the material will be posted over there before the lecture. So before coming to the lecture, you should see the PDF, the PowerPoint, and all the material going to be presented online. Normally, we live stream all the lectures on YouTube, so you could watch them, but we really ask everyone to not do that. Either use Zoom or come in person. The live streaming for people from outside ETH, just to get access to these courses for free. The Moodle is only for ETH students, where we will put some announcement, due dates, quizzes, paper discussion, assignments, and submissions. So I sent you already a message about homework 0, right? Due in a few days, maybe 4 days, right? So just simple homework, talking about yourself, why you are taking this course, what you expect about this course, and so on, right? That will help us a lot to assign you paper relevant to your interest. We may not assign the paper to you, but at least we'll make sure that whatever you're interested in already have some credit in the pool of paper. So we make sure we have 2-3 papers about the topic you're interested in. Okay, homework 1 will be released soon. So I'm going to send you another message about it. That is about the next lecture. So next lecture, we will not have it here, but I will send you more information that you have to attend a PhD defense and write a summary report about it. Very short summary, just 1 to 2 pages, about what are the goals of this thesis, what did you learn, and something like that. Very simple thing, just to teach you or get you more to use to the thesis defense. And that defense will be from our group. So I'm going to send you more information about it, and we will give you 1 week or so to submit the report, although it won't take you much of time. While you are attending the defense, you could answer all the questions. Very simple. The homework 0 is not credited. You will not get any grade for it, but it's a must. You have to submit homework 0. Without submitting homework 0, we will know that you're not interested in this course, okay? But for homework 1, it will be credited as 2 quizzes. You'll get the grade for 2 quizzes if you do homework 1. The paper review, hopefully soon, we'll send you another message about the list of papers. And on Moodle, you need to show your preferences for the papers. This is the paper the most I like, the second most, and so on, right? Hopefully, we'll give you the best or the highest score that you assign to. Hopefully not too much conflict. If many people select the same paper, then we will see what we can do. All right, so how to deliver a good talk. Do we have questions before we move on? Hopefully all logistics are clear to you. Okay, perfect. Okay, so first you need, definitely in the first slide, you need to show the title of the paper you are presenting, who you are, and who are the authors, and the venue or the affiliation of these authors. So you need to show whether this paper was presented in Micro 2022, for example, 2025, or the name of the journal, the name of the conference, plus the affiliation, whether from Google, Microsoft, or MIT, ETH, and so on. The second slide, we call it executive summary, where you summarize the entire paper in just 1 slide. The entire paper, entire story in just 1 slide. I'm going to show you some examples in the next slide, so let's not talk about it. Let's skip. Then after you show the summary in 1 slide, you need to go through the method. Of course, there is no single way to explain the actual method for a paper. For example, if you are presenting a bioinformatics paper, you don't expect everyone to know about the topic, right? So you need to provide a background. And then you start going through the details of the paper, about the mechanism, about what the paper proposed, what is the solution, what are the figures for the architecture, and so on. And then you need to show the critiques or the analysis you did. What are the strengths of the paper? What are the weaknesses of the paper? And discuss all of them in details. And after discussing the weaknesses and the strength, you already introduced the audience about what they are going to discuss towards the end. So once you tell them that there are those set of weaknesses, then they are already clear about what we are going to discuss, because this weakness need to be discussed in terms of how we solve it, right? And that is what we call thoughts or ideas. Okay, you need to come up with ideas based on different research papers, how they solve the same problem using different method. Then you give the audience more insights about how we can solve it. And also at the end, the key takeaways. So any paper, we should come up with one sentence or a few sentences that are the conclusion of the paper. We call them takeaways because they are the things that even if you don't understand anything in the presentation, at least you understand these few points that using machine learning is not best for this problem, for example. These kind of takeaways, very important. So you need to put too much effort to make them very clear, very concise, and direct to the point. Of course, after you finish your presentation, we start the discussion, 20 minutes. Start asking the audience questions and receive questions from the audience. Be prepared to answer them. Of course, there is no issue by not knowing the answer or the right answer. You need to try your thoughts. I guess maybe the author was claiming this because of this, for example, right? It's based on reading the paper. And believe me, none of us will be expert in that paper except you who read it for maybe 2 or 3 months, right? You were analyzing the paper since the starting of the semester. So you'll be perfectly expert in that field. Of course, plus the mentors and maybe the authors of that paper. But believe me, you are the most expert in this room about that particular paper. That is if you do your job well, okay? Okay, this is an example of his executive summary, how you can summarize any paper in one slide. What you need to include, motivation. What was the motivation to solve this problem? Why it's important. The problem, the goal of the paper, how they are going to solve the problem. And then either you can show the key ideas that this paper proposing or the key mechanism to solve this problem, and then the key results. And at the end, the takeaway of the paper. Okay, that is one slide, and this is a real example from this paper. I think you're right. This is your paper, right? Okay, perfect. Yeah, I just pick randomly few papers as examples from our research group, but this is a great example and very recent one presented in DSN 2022. This is another example, and you'll see a huge amount of examples just for you. All the slides are open source and our website. So if you go to the first link I showed you, the projects at Onur Mutlu page, you will see a lot of papers, and at each paper you will see PDF and PPTX. So you can even access the source code of the presentation. And then you can see all of them should have executive summary. Otherwise, we'll get angry. Right? So all students presenting anything part of our group should have the executive summary as the first slide after the title slide. Why we ask for this slide? Because as I said, people get sleepy or the energy go low by the time you are presenting and so on. So the first slide is the most important one. You convey an important message if you are energetic, confident, and with, I don't know, very good skills in presentation. So you convey the direct message to all the audience, and then they are fully focused in the first slide. If you don't do well in the first few slides, you lost them forever, okay? Either they will say, okay, I don't care. I don't know what this guy is talking about, and so on, right? So this is just to structure your slides. You need to talk about this first part, which is something easy to let's say, summarize any paper, because that is not your contribution. Someone else already did the project, did the research, the heavy work, right? And your goal just to copy paste from the paper and then reformat, massage the text and all this stuff, right? Add some information, some background. That will be the simple part of your contribution. Very straightforward. Just copy the information, present it in a nice way. What you need to work on most of the time is the second part. This is the critical analysis. And that's why we assign mentors to help you on this part, as well as the first part. So if you explain the things in your own way and you didn't explain it well, nobody will understand what you are talking about. So you need to come up with a list of strengths, weaknesses, alternative approaches to handle the problem, new ideas, some thoughts from your own, like I think this could work well if I use it, and at the end, the discussion. All of those will be your heavy contributions. Okay, so more advice on the paper review and talks. When doing the paper reviews and analysis, be very critical. Don't say, this is the best paper I read. It's well written, and all those general comments. Of course, those apply to any paper. There's nothing special about the paper assigned to you, right? So you have to be very specific, very critical. Try to come up with really solid comments. When you say this paper is strong, say why. Don't say this is the best paper and stop. You have to say why. It's the first to propose this very innovative approach, for example, using this method. This way you provide the comment and why in one sentence, and that is the best presentation, okay? Always think about better ways of solving the problem. Try to question everything in the paper. Even if the author said this approach is the best for this workload, try to question that. Try to check whether all work agree on that or not. Maybe there is a workload that contradict with this fact, right? So you have to question all the things in the paper. Read the background. Background will help you a lot to understand the concept. There are a lot of great papers that we read, but we don't understand anything from them. The idea is perfect, is novel. The results are very impactful, but the way the author explained the things, it's really not a good job. And you will lose the impact by doing something like that. If you write a paper that is not clear on what you are conveying, you lost the audience. So by presenting to the people, this is why we go to conference, we communicate with people, we build our network with other audience, and also we try to teach them about what we did. So next time they hear that this guy did this work, okay, the first time I listened to him or to her, they were perfect, right? So I would love to listen again to their talks. So that will give you a prestigious reputation for free, right? So you will have your name well known in this field. So you will tell people that I'm expert in this field, come and watch my talk again and again. Few sample text reviews provided online. We provide you a lot of resource materials for you. But one important thing that we always emphasize, apart from not being critical and showing general comments, is to avoid what we call rat holes discussion. What do we mean by that? It means you could go through the rat hole and it takes you forever just arguing about one point. For example, this paper, they evaluate workload X, Y, Z, but they forget to evaluate workload A, for example. They don't have to evaluate all workload in the world. If they show the benefits on these workloads and those represent the general workload used in the field, that is good enough. It's not their work to evaluate everything you have, right? Those kind of rat holes, you need to try to avoid them as much as possible when you start the discussion. Another thing, the metrics. If their goal is to focus on low power, maybe they need to evaluate also the accuracy, because they might come up with low power design, very small design, but you are ruining the accuracy of the design, right? So you may need to evaluate the accuracy. And that is fine to say this paper showed the power measurement, but they didn't talk about accuracy. That's fine. But if their goal is not to build a very small design, and it might not be fair to ask about all these points. So try to avoid things that, okay, it's good to include them in the paper, but they are not critical or the goal of the paper. All of those rat holes, because, okay, you can include this workload, and you can include this, and you can include, so what is the end? After how long requirements you need to satisfy the reader, right? It will take you forever. This is another cartoon figure for the same thing. And this rat hole problem is already described in this book. So we recommend you to read it, especially this page. So you can see in the beginning here, I try to highlight an issue that we had in academia. When you write a paper or you write something describing your work, you send it to a venue, like the best conference in the world, for example, or the best journal where you want to publish your work. Now you get assigned to reviewers. Sometimes you get 6 reviewers, and those reviewers sometimes knowledgeable, sometimes very beginners, like could be student as you, it could be undergrads, could be interns, right? They might still be knowledgeable, but they might still be not knowledgeable, right? And their reviews might be just creepy. Really, it's not relevant to what you are doing. They might tell you, your design is the worst design I have ever seen. And on Twitter, if you are following some of the best researcher, for example, in some field, you'll see some funny stories. For example, reviewers ask the author to read about this seminal work because it can educate you more about the topic. And who's writing that seminal work is the same author. So they ask the same author to read his own paper to learn about the topic. Of course, the reviewers doesn't know the author, and the author doesn't know the reviewer, right? Everything is hidden. So we don't know this information. That's why these things sometimes happen, right? So it's very funny to always get derailed by the reviewers. And in the same book, you can see a list of reasons what the reviewers might think be good to mention in the reviews. And some of them, for example, mention, if the thing is working perfectly fine, why we need to change it? Why we are proposing processing in memory if the CPU is working fine? Something like that, right? You may get very silly comments in your work, and don't get angry. It's not personal. It could be the reviewer themselves are not aware about the trend or the state of the artwork. So you need just to answer them, provide them more comments, more references to read. Hopefully they will be convinced. So these kind of things try to avoid whenever you analyze an existing work. Okay, more advice on work, so you can check these resources. As I said, all the slides online, so you can check them and get useful or get more information about. Okay, this is a painting. And what is so special about this painting? Anything attracted you? Anything special? Yes, please.
The cloud sort of look like UFOs, but I don't know if that's the point.
Yeah, so as many of you, I can see from the first expression, like, okay, what is so special? I don't know. It's just a painting, right? Nothing amazing over there, right? And this painting was done by this guy, Salvador Dali, okay, in 1924. Now, how about this? What is so special here? Drawn by the same guy. How about the painting itself? Very different, right? Excellent. So this is very different painting done by the same guy just 10 years later. So he was improving himself. He drew very normal painting the first try. Very normal, right? Maybe some of you can draw better, maybe. But this one is totally transforming the paint. So you need some time to think about it. And you may get really different stories about the same paint, right? So you could say like, okay, this story of a woman I don't know what's going on over there and so on, right? You start with your imagination. And that is something really innovative. This is the same guy, just 10 years later, right? And that's why I ask you, even if you check my own presentation 5 years back, right, while I'm doing PhD, for example, you'll see it totally different from what I'm doing now, really different. So people, especially those who care about themselves, used to change themselves for better. So they keep learning their faults and then changing them. That's why it's important for you to try also that experience. Present online, fix the issues you got, present again online, again. You could post your first try presentation on Facebook, for example, ask your friends to give you comments, right? That is before to come to the lecture or to the class. And next time you present, you'll see totally different thing, hopefully. The takeaway from this course: learn the basic principles before you can choose to break them. What does that mean? You cannot extract weaknesses of any existing work without learning the background, the basic, the method he proposed, she proposed, and so on, right? That's very important. You have to be very knowledgeable, let's say, about the paper you are presenting. So you present the background, the method, the design in a very good way so that you can come up with a good discussion. Without doing that, you cannot come up with really solid weaknesses. And for that, we believe maybe we sometimes give you like, you have to do this, you have to do that, but at the end you say, okay, this is a lecturer or professor for 20 years, he has a lot of experience, he cannot do something similar to him, right? But that's why we give you a list of presentation from student in the past semester. So this Jennifer presented about bioinformatics last semester. She chose one of the paper from our group. So we ask all of you, maybe go and access it, check the YouTube, it's already public on the previous semester. This is the link. You can see the video, the slides, and so on. This is an example of very excellent presentation. We have a lot of other very excellent examples. For example, Yannick, he also presented about another thing in processing and memory, but he decided at the end to work with us on bioinformatics for processing and memory, for example. And this really was an excellent example on how to deliver a talk. This is another example from Sufi. I think she was last year, not last semester, but it was really a great example. And she came up with very novel ideas at the end that we decided to crop her talk and keep the last discussion part offline. So we keep it secret just for us because it's part of it, ideas that we are working on. It was really perfect discussion. So you won't see the discussion over there. That's why it's very short, just 30 minutes here. And we have many more examples. And if we didn't mention them here, doesn't mean they didn't do a great job. They still may get the perfect grade for the course, right? But just because we cannot mention all of them. This course being offered, I think, 9 times or so. And every semester we got really good students. This is another example with the discussion. And whatever you would like to check, just go to the course page. At the side here, you will see the past courses. You can access each of them, then go directly to the lecture schedule. You'll see all the YouTube if the student decide to make it online. Some of them, you won't see the YouTube because just the student were shy, okay? Hopefully all of you won't be shy. All of them available on YouTube as well. And yes, then how to participate. Any question before we move on? Okay, I want to drink water, so I was hoping someone will ask a question. Sorry. Okay, how to participate. Okay, so basically you want to prepared. What does that mean? You really need to skim the paper before you come here. So you can read it, read the abstract, for example, go through the evaluation, and then think new ideas. You can put yourself in the shoe of the presenter so that you really need to come up with a discussion point. So you yourself, even if you are not a presenter, just come prepared and come up with new ideas so that you can ask something really fruitful. Be very critical when you explain the things. As I mentioned, don't mention something like very general that apply to any paper. Just be direct to the point. And a brainstorm, you could ask the mentors, you could ask the presenter themselves just before they present, you could send them email. I'm going to ask those questions. Do you think this is valid? This is whatever. Do you have pointer around that? I'm going to ask you this. Maybe you can be prepared for this kind of questions. You can come up with ideas for us and so on. You need to pay attention, discuss, contribute. That will help you to solve the quiz and also will help you to participate in a conference setup. Participate online through the Moodle and through the course. Ask questions. You can send them in Zoom. You can send them in Moodle. You can raise your hand and ask the questions directly. The guided talk preparation. This is an algorithm. We are going to send you a detailed version of this algorithm once we assign you the paper. You can see a copy of this algorithm also in the previous semester web page. And if you follow precisely the steps we mentioned, the algorithm, everything will be perfect and smooth. So please make sure once we assign the paper to you, directly contact your mentors, ask them to schedule a meeting, even if you are not ready. Just tell them, I think within 3 weeks, I'm going to be ready with the first draft of the slides. Of course, slides here doesn't need to be perfect. Just come up with outlines, things that you want to include. You could just include screenshots from the paper, for example. Just things that you think that this will be the structure of your presentation. Target the mentors, send them email. I'm going to schedule in 3 weeks when you are available. Schedule the first meeting. Discuss with them the structure of your slides, the things that you are going to include. And then you need to discuss again in another meeting. So ask for 2 meetings. That is at least 2. You can schedule 3, 4, whatever needed for you, okay? Until you feel really confident. But at least we require 2 meetings with the mentors before you come up here to the stage and present to the public. So that's why you need to check your date and arrange for all of those accordingly. So the sooner you act, the better for you. And then you need to study the paper. We say here 3 C's: carefully, critically, and creatively, okay? You need to consult with the TA, with all audience, with all mentors, with the students, with us, for example, whenever you have some issue to understand something. Create a draft presentation. You could start from creating this while you are studying the paper, because sometimes you forget what you read. So while you are reading the paper, try to copy paste to the slides directly, okay? If you are lucky enough, you may find a previous presentation for the same paper, a previous video on the same presentation. That is something good and not good at the same time, right? It limits your imagination, your creativity in creating the slides, because you already said, okay, the author created this set of slides. I cannot do better than them because they are the authors, right? And then all your imagination is limited, right? That's why it's not good for you to reuse them. But it's okay to reuse some slides, especially the first part of the presentation, which is about the core work, but not about your own contributions. For example, the method. They may come up with very nice animation in PowerPoint about the key mechanism, how the paper works or how the method works, right? Those things you could copy paste, something like that. But other than that, I really don't recommend that. Especially the discussion, the critical points and so on, okay? And always discuss with your mentors whether you want to use the slides or not. They're going to give you more recommendation about what you can do and what you cannot. Meet advisor, get feedback. As I said, all those are not in order, so you could still meet with the advisor before, just discuss any concern about the paper, for example. While you are studying the paper, you could still create the draft presentation and so on. But we will give you more detailed algorithm once we assign the paper. All right, so the grading for this course, how you can pass this course. Hopefully this is not the goal of all of you. Of course, passing the course is very fine, perfect. Everyone aiming for having pass or 6 out of 6, but hopefully that is not the goal. The goal is to learn in this course, right? We're going to assign 60% for the presentation. So most part of the grade is just for the presentation. These are the things that we use to evaluate you. All the mentors during your presentation will have a form to fill online, and they're going to give you a grade while you are presenting. If you are not self-confident, that's going to reduce a bit your grade, okay? You have to be very confident, very happy, very energetic. Drink a lot of coffee or tea before you come here, okay? And 30% for the synthesis report. So as I said, 2 parts in the reports, they are really easy to answer if you are paying attention. If you really pay attention to all the topics, it will be clear in your mind how you can categorize them or cluster these topics. For example, there were 5 papers on this topic, another 3 in memory processing, another 2 in this processing, and so on. That will help you a lot to answer the question we ask in the report. There are 10% of the grade on the quizzes and the attendance. Of course, if you do this, we assume that you already attended, okay? But as I said, it's mandatory to attend all meetings, and you are allowed only to skip 2 for a reason, valid reason, let's say. There are 10% as a bonus for the participation, those especially who are very active in the discussion. Normally, we give them some bonus, okay? Which is 10% at most. The feedback, we always encourage everyone to give us feedback on the course itself, on anything, logistics, the grades, anything basically. So there is a very important chunk of the synthesis report just about the course, okay? We ask you how we did, how was the course itself, anything to improve, and so on. And normally we also allow for the presenter to get the feedback about the presentation right away. So once he's done with his presentation or her presentation, we are going to give you feedback that you did very well here, but you missed talking about this, and the paper was discussing this, but you missed it for some reason, okay? So that's something nice. So you're already aware about the things and you didn't forget, so we give you the feedback right away. The expected schedule. So as I said, next week won't be a lecture here, but we will ask you to attend the PhD defense. That is a must. You have to attend it, either online or in person, and then write a report about it and submit it in a week or so, okay? Hopefully that is not a heavy workload because the defense time is exactly the same time of the lecture. So that's something good for you, okay? And your presentations hopefully will start on 13 October. So we were planning to scare some of you to drop the course because now there is 28 students registered in this course and we have a place for only 22. So if you're not serious about the registration, please drop it as soon as possible. If you really want to take this course, yes, stay. We would find a workaround how we can increase the capacity. But for those who are not really serious about the course, just drop it. So you allow those on the waiting list to join the course. We have a large number of people on the waiting list, by the way, although we have 28 places for this course. But regardless, even if you want to stay, just stay and we will see another solution for that. But as I mentioned, please drop the course if you're not serious, okay? So your presentation will start on 13 October, and that will allow us for having 22 presentation, which is 11 days, 11 weeks, basically. Each presentation, 50 minutes. That includes the discussion end to end, because we have 2 hours for the lecture, okay? The paper assignment will be done by you, basically, at first place. So we'll ask you to show your preferences for all papers. We won't dictate it. We won't ask you to present this. So it's up to you, whatever topic you want to pick. But we will do our best to give you your top favored paper, okay? Hopefully. Homework 0, don't forget it. Anyone that did not submit this on time, we assume directly not interested in the course. Homework 1, likewise, but this at least will be credited. This to be determined later. And the second part of the lecture is just more information for you, just how to learn about grad school, how to choose advisor, how to choose the research topic, how to work on research problem, and so on. All those material very helpful for you. It's not part of the course, but really an important ingredient of this course, how you present successfully, okay? Either you present yourself, for example, going to a job recruitment interview, how you sell yourself, how you present your CV, and all these stuff. So those are very important resources. I'm going to flash them quickly, but you already have the links, everything in the slides. You can access them online. That is the first part. I have another 300 slides, but I'm not planning to present them. Maybe we can present just small first part of it, and then until the time passes. What do you think? Ready? Want some caffeine? The 300 slides? Yeah, because once you hear 300 slides, then you block, right? We have, yeah, about 13 minutes, right? So I'll keep presenting until the 10 minutes is over, and then we can stop, right? Yes, please. Very smart question. Yeah, so I think it will be just 3 weeks where we present, and after that you guys will start presenting. So it won't be heavy workload. It won't be always this way. We present a lot of slides and so on, right? Yeah, but the second part is more about the research, how you do computer architecture and so on. Probably you already been going through these. Stop share. Second part. You can keep asking questions, so I don't go through these slides. It's up to you. Have 10 minutes. Anything interesting to discuss before we go through this? I cannot see this screen. I need to share. I cannot see the cursor. Need to share for the people in Zoom. Yeah, hopefully the people in Zoom can see now the slides. Okay. Why taking this course? Why you are taking this course? This is one of the questions in the synthesis report, and I copy here one of the responses from the synthesis report from student like you, okay, from the previous semester. So the first response said, cannot see clearly, but computer architecture is, well, for the most part, pretty fun. Okay, hopefully you agree on that. And this course helps here, let's say, because I know who wrote this, what the current state of the field is, or what are the current state of the artworks. So hopefully that is one of the reasons why you are here. You want to know what is trendy in computer architecture. She also wanted to take part in a course where the student actively participate. It's interesting to hear how different people think about the same issue. So you might think that the author were thinking this way, but you may figure out that was wrong, that you got feedback from mentor, from professor, or whatever, and you figure out that there might be another way to think about this. And yeah, the student learn a lot by catching yourself saying something nonsensical or by not understanding something really obvious and so on, right? That will help you to learn something from this course, hopefully. And another response was that the student didn't find any relevant course where she interested in. So that course was offered in the right time where she find it very interesting, especially for computer architecture problems. And the student decides that she wants to choose related advanced courses in the third year and put my study focus on computer architecture. And I think we contact her to join our group to do research because she was one of the best students doing research. There's another guy. I think this guy had 2 goals to join this course. The first one, the interest in computer architecture, and the second interest to seize an opportunity to start doing some research. And while the seminar course is going on, they directly contact us and they start the research during the semester. So they didn't wait until the semester ends. Okay, even if you are not interested in computer architecture, but you are here just to learn how to present, for example, there are other ways to approach this course. For example, you are looking for formative experience. You want to form something out of this course, for example. Whatever this experience is, as I mentioned, could be learning how to present, how to analyze, how to discuss, how to present, anything. It could be something just to increase your confidence in yourself. Just want to increase the confidence so that you can present to any audience, for example, okay? Reading, analyzing paper will help you a lot in future. High investment, high return. If you invest in yourself, that will return directly with you with high benefits. You got guidance from 3 top researchers in the field. Those are the mentors plus us. And normally we ask the student if they want to recommend this course to their friends. Some of them say yes, some of them no. What is the main reason why they don't want to recommend it? They said this is very heavy workload compared to other seminar courses. Yes, we know that. We require a lot in this seminar course, but that is for your benefit. At the end, we don't gain anything. Either we make it heavy workload or light workload. You are the main stakeholder here, okay? Some of them really love computer architecture. That's why they are here to learn more about this topic. Learning experience is long-term, right? So even whatever you are 50 years old or 60 years old, you still want to learn more, right? We never end learning. With the critical thinking and decision-making. And why study computer architecture? That is a different question. Hopefully all of you already studied computer architecture course. How many of you took computer architecture? All of you? Some of you? Whatever, computer architecture, not DDCA, not digital design computer architecture. The computer architecture master course. None? Okay, so yeah, I'm not sure if I teach you about bioinformatics that time, but normally we teach that during the computer architecture master course, which is offered normally in fall semester, once a year. Okay, I'm going to skip why you want to study computer architecture. Hopefully you are aware about that from the DDCA, but normally there are different platforms and different goals, right? When you build this like system is different from when you build portable devices, right? Likewise to this. They are really different goals and so on. So this is iPhone 14, this is iPhone 13. There are real fundamental differences between the 2 devices. Likewise, this is iPhone 11. This is 4th generation, and they are still really different, right? This is 3 cameras. Still, we have 3 cameras, right? It's really different. So we have different goals. Hopefully not. Those, for example, machine, when you want to build them, right? The drones. So you want something lightweight, something low power, something small size, and so on, right? So there are different requirements, different goals whenever you target something else or something different. This is Mr. Bean. He built what is needed for him to achieve the goal, right? Regardless the tools you are using, regardless whatever reach you or help you to reach the goal, still achieving the same thing he wanted to achieve, right? And that is what is important, to achieve what you are looking for. Same thing for self-driving cars. Who was thinking to put a very heavy machine just to compute the things for, right? It sounds crazy to have all those computers in the cars. Not only that, but also for Tesla, for example, they use redundancy in their own chip. So the exact same chip is over there, right? Within the same board. Why is that? To increase safety, for example. So if one of the chip faulty, then the other is still working, providing the same output, right? So things are really crazy. When you build supercomputer, it's really different because you need to worry about cooling these things, right? These facilities spend a huge amount of power. This is one of the supercomputer in Japan I was telling you about. We were lucky to visit them while they're installing the supercomputer. I was representing Safari. I went there in 2020. And they built this supercomputer over there with specialized hardware. So they didn't just stack millions of CPUs and that's it. They built even the chip to do the processing over there with high bandwidth memories. Over there with a lot of storage, a lot of memories, so that you can do the computation very efficient. Likewise, from NVIDIA, this is very latest GPU that they offer. They call it H100. In this architecture, they have a customized portion of the chip just for doing dynamic programming problem. Just for that problem. It's no longer general purpose, right? Very specialized to do something in specific. Yes, they can do any other things, right? But the full or the major part in this architecture is the dynamic programming solutions. Why is that needed? Think about genomics, right? One of the important problem is sequence alignment, and that is where you do string matching. So you have a piece of your DNA, another piece from another guy DNA. You want to compare them and find the differences. What causes a disease, for example, right? So that's very important, and this is how we are specializing the architecture. There are large examples we can give you. There are a lot of slides in this talk, as I said. But what I want to highlight that here we talk about bioinformatics. I was hoping to cover some, but there are a lot of resources inside the slides. There are a lot of videos. For example, let's see which one. So going through the videos, you will see several talks about how you build efficient architecture and you build efficient algorithm to solve some problems in bioinformatics. And this is one of the recent paper that we published. Even if you are a beginner to this area, to bioinformatics, we hopefully cover everything needed for you to understand the area. So if you're interested in bioinformatics or genome analysis or whatever, we recommend you to read this paper. This is the top resource that you can find covering different aspects for expert and beginners. This is the recent paper that will be presented just next week called GenPep. Hopefully you will find the talk soon on YouTube about it. And here we change the entire pipeline for genome analysis to do innovative solution. So without changing the things we have, you will never get an excellent solution or excellent results out of it. If you keep the things as they are, they may not be as efficient as you think. I would stop here. I wouldn't go further, but please check the slides. They are already online just for you. There's no exam, nothing, no questions about them. So feel free to check them. The most important part, the videos. Whenever you see video in a slide, please check that. That will help you a lot. For example, this one. And many more. You'll see a lot of videos, especially for our recent work published in Nature method about microbiome discovery, and many more. You will see a lot of exciting work that we did in our group and in collaboration with other groups on using computer architecture. This is some feedback we got on Twitter, many more. Let me stop here. Okay, any questions about the logistics, about the course? Yes, please.
You said we were like having mentors, right? Do we choose them or do they choose?
You don't know them, right? You cannot choose them. We normally assign them based on the paper you choose. First, you need to choose the paper, right? Once you finalize the assignment, then we assign 3 mentors to each paper based on who is the author of the paper. So normally we'll do our best to find, to assign you mentors from the authorship of the paper. That will be great benefits to you, right? But if you want a specific person, why not? You can send us email. we'll do our best to assign if there is a valid reason. Okay. For example, I'm thinking to continue doing research with him, her after the semester, something like that. Yes. Yes. But you are free to check all the rest. Again, we cannot give all examples. As I said, there's 9 semesters for the course, so there are a lot of great examples. But those are really good set of examples. And their slides should be public available, everything public available. So you can check them and access them. Any further questions?
When is the paper selection begin now?
Within a week, hopefully, because we have to start on 13 October, the first presentation. That means you should be preparing your slides 2 weeks before that, right? So within a week or so, you should be knowing your paper, hopefully. Yes. So it's already available from the previous semester. You can go to the previous semester, check synthesis report to the left side. You will see the full report over there. But it's actually 2 parts, as I said. The first part asking about all presentation, the second part about yourself, whether you want to do research with us and all this stuff, what to improve in the course and so on. Yes, please. Normally we do the assignments for the dates. Why is that? Because we cluster them based on topics. So it makes sense to present all processing and memory papers as one chunk. But again, we are flexible to move who's first, who's second, and so on. If you're not available in this week, you have exams or military service or whatever, we can switch them. Yeah, always send us emails about these. Yes. Okay, so it's just 10% of the course grade, right? So that means you'll take about 11 to 13 quizzes, right? So I think if you answer 70% of them, you should be fine. But please do your best to answer everything, right? As I said, you don't need to study the paper in advance, although we recommend to do so. Hopefully all the quizzes, they are already so the way we create the quizzes, by the mentors themselves, they create the quizzes with the help of the student, and then we assign 2 more people to judge the quiz questions. So we go through the quizzes, the answers, and we try to change, reformulate. We really spend a lot of efforts offline that you're not aware of, how we come up with the quizzes and all this stuff. So we make sure, hopefully 100%, that you can answer them without reading the paper, but just watching the lecture, okay? Yeah, I speak a lot today. Yeah, at least your turn will be very soon. You need to speak a lot, right? All right, that was a great start for the semester. Thank you so much, everyone, and see you next week.